Welcome back to another video, and today we're going to be learning about improper integrals, or how to integrate a definite function integral of a function where a point on that integral doesn't exist. For example, in question 1, the point 8 doesn't exist because we get 1 over 0, which is undefined. So what we can do is we can use a limit to approach this value 8 instead of actually using it, which means we can get what the value would be if it wasn't undefined. So to do number 1, I'd first use a limit as a number b approaches 8 from the left side, since on the integral 0 to 8, it's approaching 8 from the left side of the integral from 0 to b now, which represents 8 of 1 over the cube root of 8 minus x with respect to x. So to solve this, I'd use u sub, and then negative du equals dx. So the limit as b approaches 8 from the right side on 0 to b is 1 over, or is u to the negative 1/3 du. We could change these bounds to u of b, but we're just going to be switching it back to x anyway. So then we get the limit as b approaches 8 from the left side as 3/2 u to the 2/3 at b to 0, and then we plug x back in for u, so 3/2 8 minus x 2/3 as b is approaching 8 from the left side at b to 0. And as you can see now, we can now actually plug in our value of b. So 3/2 times 8 minus 8 to the 2/3 is just 0 minus 3/2 times 8 minus 0 to the 2/3. The cube root of 8 is 2, which is squared is 4. 4 times 3 divided by 12. 4 times 3 is 12, divided by 2 is 6, which will give us our answer. Another type of improper integrals is when it's approaching infinity or negative infinity. And to solve this type of questions, we'd use a limit where we have our value approaching infinity now, so we can get a definite integral. And then to solve this, I'd use u sub as well. So I'd get the limit as b approaches infinity of 1 over pi on the definite integral 0 to b of cosine of u with respect to u. And then we know the integral of cosine of u is just sine of u. Since it's definite, we don't need a constant of integration from b to 0. And then we'll plug in our u back, which was sine of x from b to 0. So, as you can see here, if we do plug in this value, infinity, this function will oscillate because sine oscillates towards infinity. So what we can say, this function does not exist or diverges. And this function up here would converge since it goes to a finite value or does exist. So let's take a look at another example. So we see we're going to negative infinity. So we have the limit as a approaches negative infinity. We integral a to 0 of x times e to the negative 2x dx. To solve this, I would probably use the tabular method. Or to integrate it. Then I'd get the integral as negative 1/2 x e to the negative 2x minus 1/4 e to the negative 2x on 0 to a. So then I can plug in my values. could simplify it further. And then if we plug a equals negative infinity in, we get negative 1/4 plus 2a plus, or 2 times negative infinity plus 1 times 4e to the 2 infinity. Since if we plug negative infinity here, it moved to the numerator, which means this function diverges as well. And now lastly, this is going to be a tough one to spot, that you have to use an improper integral. But as we can see, if we use the value 0, which is on the integral, negative 2 to 3, then we get 1 over 0, which is undefined. So we have to use an improper integral. And we'd actually have to use 2 here, since we have to go to 0 and then go to 3 separately. So I'd have the limit as b approaches, or we can rewrite this as 2 different integrals actually. Which is kind of what I was mentioning earlier, where we'd have 2 different integrals. So the limit as b approaches 0 from the left side of x to the negative 4th, the integral of x to the negative 4th dx from negative 2 to b, plus limit as a approaches 0 from the right side, since on the integral 0 to 3, that's where 0 is, a to 3 of x to the negative 4th dx. So then we get as b approaches 0 from the right side of negative x to the negative 3 over 3 at b negative 2, plus the limit as a approaches 0 from the right side. The integral of x to the 4th is negative x to the negative 3 over 3 at 3 to a. So we get the limit as b approaches 0 from the left side as negative 1 over 3b cubed plus 1 over 24, plus the limit as a approaches 0 from the right side, negative 1 over 81 plus 1 over 3a cubed. And then as b gets smaller and smaller, this value will get bigger and bigger. And as a gets smaller and smaller, this value will get bigger and bigger. So this series will be infinity plus 4 minus 181 plus infinity, which we can confidently say diverges.